Thanks, guys, for coming to watch our talk. I'll start by saying this is a very ambitious talk. We describe like a very complex system, so stop us at any point to ask a question. The important thing is that this is useful and like helpful. So if you want to derail us completely to have a discussion at some point, also cool. So yeah, I'm Alex Neuhausen, and
I'm Nicholas Fries.
And we are both presenting this talk, not as a gimmick. I don't know why more people don't do talks together, but we both like work on the system, and so we submit it together. So the talk's called E Pluribus Viewum, breaking up a massive view front end. Who knows what E Pluribus Unum means? Yeah, out of many, one. It's on every dollar bill that you have. And so the idea being, that's it. If you just take that from this talk, that these guys are building a bunch of individual systems and stitching them together into one single page application, that's kind of the point. And then we're just going to tell you how we do that, basically. So first we'll introduce ourselves, so you know who's presenting. So I've got 10 years of experience, full stack development. Before I was a developer, I did hard science and studied electrical engineering. And I also play guitar and DJ on the side, and if you see me later and you thought this talk was decent, you can buy me a Negroni.
I've been programming for about 15 years. Originally wanted to be a game developer, but made more money doing this. Used to be a TL, decided I wanted to program more, so I do much more programming now. Love sci-fi, and buy me a whiskey sour if you get a chance.
Cool. So we'll jump into it. So the kind of motivation for this talk, we're going to start, you may have read about Conway's Law, which I love as sort of a human engineering thing. And it basically says that the system that you build, any sufficiently complicated system, will look like the team that builds it. So a cute way of saying it is a group of n persons implements a COBOL compiler, and this was developed in the 70s, this law or whatever. There will be n-1 passes, just because someone in the group has to be the manager, and everybody else is going to work on one pass of the compiler. So we've realized this in our own team that we work on. We work on a very large web application. In the web app, and think about this in your own company, the web app looks like the different teams that build it. If you have a hard separation between your front end and back end, you'll find you have like a lot of weird emphasis on the API. If you have individual feature teams building, say, one team is building just a document viewer for your PDFs and stuff, that's going to feel coherent. And you'll kind of notice that like things maybe feel a little different on some other part of the site, say your shopping cart or whatever. It's a really interesting thing that like your website looks like your bureaucracy a lot of the time. So how do you lean into that? If you know that that's a thing, you're going to have lots of different teams making different parts of your web application. So when we say large scale, we mean a large organizational scale. So we have about 40 contributors to the like front end of our web application. We'll tell you a bit about what the application is. How do you lean into that organizational structure and actually use it to your advantage? So the agenda of this talk, I'm going to start by just describing how we use Vue on Bloomberg Law, which is the legal research website that we work on, which is this absolute behemoth of a thing. And then Nick is going to really dive into the guts of this architecture, and Nick built most of it. So this is where you can really like stop him and ask questions, and he'll be happy to explain stuff. Then I'm going to walk through kind of what it looks like as a developer using this system to try to sell you on if you were to architect a large-scale Vue application. It makes our lives really easy. Our CI/CD is like awesome now, but it took us a long time to build it. And then Nick will kind of kick off discussion at the end by comparing this with like other things we could have built instead, and like why we don't necessarily regret the architecture we ended up with. Yeah. Yeah, we definitely can like, I think I can just share the like Google Drive slide deck or whatever in like a read-only format, and it'll be fine. So yeah, so yes, the slides will be available. Pay attention though, but in a relaxed manner. So yeah, to start off, to describe this web application that I'm alluding to, why do we have 40 developers building this thing? So we build a website. It is like Google for attorneys. And when I say like Google, it means the core functionality is searching and like looking at documents. A lot of what attorneys do is find the right document, be it court precedent, be it something that explains how you as an attorney should file your paperwork with the court. But also, like Google, there's a bunch of other tools that we make. It's a subscription service, and it covers almost everything. So if I want to see, say, how the election, I don't know why that's going on. Anyway, if I want to see how, for example, the election last night is going to affect my legal practice if I do certain kinds of legislation, or I'm an attorney who does abortion rights cases, or I might argue in front of the Supreme Court, I can see how that late-breaking news is going to affect my profession. I can see new workflow tools. If I'm currently arguing a case and new evidence is submitted by the opposing counsel, that will show up in Bloomberg Law first before you even get notified by the court. So it's a very useful tool, but as you can imagine, it's incredibly broad. It does a ton of stuff. And then a quick aside, we are hiring. If you think it sounds cool, we're eagerly hiring people. Move to New York City, you can work with us. We're in a really nice office building that overlooks Grand Central Station. It's a pretty cool company. So talk to us afterwards too if you're looking for work or think this is interesting. Okay, so having described that very large application, it's gonna go in and out like this constantly. Cool. Having described that large code base, we started encountering issues, right? So like Daniel Kelly in the last talk talked about, Daniel Kelly in the last talk talked about kind of like good hygiene or good procedures to follow almost that will let you work at large scale. But even that has its limitations. So when you get to the point of 40-some developers all committing to like a giant Vue application, you start having issues. It's going to happen. So if your company is growing and you're building a giant application, some things that will happen is people will break each other's code, just like accidentally. They're on totally different teams. Somebody changes how the search results widget works for document searching, and they didn't know people were using the search results widget on a totally different part of the site for some custom alerting thing. And so they change the styling or they change how the props work on that interface, and they break someone else's thing. So that's bad. You also are stuck with, if you're doing, say, daily deploys, or you're deploying this giant front end, everything goes out at the same time. So we are on a daily deploy schedule, and all the code has to ship at once. And so what this means is if you have a deadline, some teams, like we have a demo for an important client today, nobody commit, like nobody merge to master. Why? We've just stopped the entire organization for this thing. Or if something breaks that's important and we're getting calls and they want to roll back the latest release, all 40 developers, everybody's code, every other project basically stops and rolls back until we get the thing fixed. So it's painful, it's not very productive. And then us personally, we're having the issue, we were building, we had so many components and we're loading so much code that our actual local builds got very slow. So you would update, and granted, we are on Vue 2, we hadn't implemented Vite yet. This all kicked off about 3 years ago that we built this system, but it sucked. It got very slow. So what do we have now? What we have now is we have a bunch of different repos now. So I have these little CI/CD infinity loops or whatever of release, and they are separate. These are little child applications. There's a document viewer application that we build. It has its own repo, its own tests. We have a little search repo, not even little. That itself is thousands of lines. But these are all independent, almost projects or applications themselves. And then we have a core application that stitches them together. And we've written a bunch of automated tools, and we use containerization using Docker to effectively build the whole front end in a container to run testing on before the thing deploys. So that's your quick preview of this cool thing that Nick is going to dive into the guts in just a minute. So first the jargon, so that it's clear what we're talking about. So we're going to use the term shell a lot. That's what we call this central application. Sometimes we call it core, but mostly shell. And it's your terminal, your shell program, and that it's meant to load other programs. It's meant to load and run other applications and make them work together. We'll talk about child applications or feature applications. So our search app or document viewer app. Those are the children that are loaded and stitched together by the shell. We're going to say large scale a lot, and large scale in this sense is large organizational scale. If you have a lot of contributors, this really helps us with that. Large code base as well. Not necessarily a ton of customers, although probably those will go hand in hand. And we'll talk about safety a lot. So we've heard throughout this conference about how testing makes things safe. You can refactor if you have lots of tests and you don't worry about breaking your application. So for us, we have safe development that we can make changes to these child apps, and you no longer have to worry that you're going to break something all the way on the other side of the site, written by somebody who's not even in your same city, for example. And then finally, this term we learned yesterday, DevOps. We didn't realize this is a DevOps talk. So this is a talk really about tooling for the front end, engineering for the front end. So like DevOps, but primarily related to the front end. And with that, I'm going to hand it over to Nick, who's going to dig into the architecture.
Thank you, Alex. All right, so I'm going to do this step by step. There's a lot of moving parts in this thing, and so yeah, we'll go into some detail here. So the idea is we want their disparate teams to be able to have the freedom to work within their domains as they want, but to make sure that they're able to build into a much larger ecosystem safely and confidently. So yeah. So the idea is we originally had a very large Vue code base that had many different applications and responsibilities, all of the JavaScript build logic, all of the application-specific components, like the document viewer he mentioned, search results, things like that, all of the shared components they use for checkboxes and things like that, and any state stores and all the regular shared, everything was in one bucket. So that means they all got released together, they all got deployed together, and they all potentially broke together. So the idea is we broke it up. And so each of these different domains now has their own dedicated CI/CD release process standards. And we'll go into a lot more detail on each one in just a moment. But this is really the meat and potatoes of it is take one thing that releases or breaks together and break it into smaller things that can now release independently and safely. So here's an example. So the entire thing would be the shell app like he was talking about. But inside of that, you've got a navigation app up at the top. You've got a complicated judicial analytics application, and that's part of the document viewer that you see is behind that thing. There's a lot of different teams contributing just to this one page. And on top of that, all of them are sharing similar components, like buttons and checkboxes and input boxes and things like that. And so for this talk, though, we're actually going to repurpose it into a potential Connect.Tech conversation. So we're not actually going to be showing you Bloomberg Law from this point forward. Same idea, but we're a theoretical Connect.Tech application. So instead of search results and document viewer and judicial analytics, you have the navigation, you have the schedule, you have tickets. But for the same idea is you want each one of these might be different teams, might be in different states that doing their own work, but when they release a new version of their different application, it is going to be in prod in a few minutes, safely and confidently. So here we're actually going to take a step-by-step through the process from a feature developer opens a feature on one of these children applications, like a new feature on the Tickets app. How does it make it all the way to prod? So I'm making a new feature to the Tickets app. I open a pull request to my Tickets repository. And two things might happen. Either I don't need any QA, it's too simple, or for whatever reason I don't need QA, I just merge it. Or I do want QA it. But like I said, it's only one small part of the application. So how do you QA in a larger integrated into the larger ecosystem? So we use a tagging system that if you tag a pull request on a child, it will generate a pull request to the parent using that pull request of the child as the version of that child application. So that means now you're going to get a full build of the shell that's running your pull request before you ever merged anything. So that way you can give now a link to this to your QA people, and they can go QA it and stuff. And if they find issues, you can iterate a few times until you're fully confident that your feature is good. Then you merge it. Now we have a convention that in our projects, whenever one of the children, or whenever any app merges to master, master is always designed to be releasable, so a new version is going to be triggered. So I've merged my feature branch. Now a new version of my Tickets app is going to automatically get generated and pushed to NPM. So built and pushed to NPM, our internal NPM. And so now we have a separate system that says the shell application, whenever a new version of a child application is generated, it notifies a coordinator system that we have that a new version is available to be built into the shell. So now a new version of the shell, a pull request to the shell will be opened now with a new version of the child being bumped. So instead of a pull request that it's referencing, it's actually referencing the new child version in NPM. So it's just the PR will be very small. It'll just be like a package.json change with a version bump in it somewhere. And that's it. But it's automatically generated. And what will happen here is end-to-end tests along with a bunch of other stuff will run at CI for that pull request. And what will happen is if all of it's happy, including all of the very robust end-to-end tests, which are actually, end-to-end tests are notoriously flaky and slow. So one of the things we've done is we've actually broken down an umbrella suite into a bunch of smaller targeted suites of end-to-end tests. So for example, we'd have a dedicated tickets end-to-end test suite. So when the parent shell application is building a new version, it recognizes that there's a version bump of the tickets app, it will run the tickets end-to-end suite. And that way, run all the end-to-end tests. And do your best to keep those stable. You're constantly be moving on those, but so if it all goes nicely, that will pass. And when CI passes all the way on these integration PRs, it will automatically merge. So once CI goes through the entire process, and all the end-to-end tests pass, and it's a new version, the PR will be merged to the shell. Now, whenever a shell, like I said earlier on, whenever a PR is merged to master, we generate a new version. That includes the shell. So when this automatically merged PR is merged to shell, a new version of shell gets generated. So it gets generated, and now the shell application is not an NPM package. It is a set of JavaScript bundles and code. And it gets uploaded to an asset server, S3 for example. And so that way, it is now available to be consumed by customers. Once we know it's been uploaded, it's all there, then we actually have a versioning system that all our client browsers know how to, whenever our client makes a request, our system tells them where to request these assets from. And so when this new version of shell goes out, it will now notify all new clients, or any client that is currently making a new request will now get the new code. So I'm going to go much more detail on each part of this in just a moment. But the idea here is, at the beginning, I opened up a pull request, and I merged it, and I didn't do anything else, and it is in production, safely and confidently. I'm going to go into much more detail on this in just a moment. So the idea is, what is shell? Shell is purposely thin. It's only supposed to be stitching together these children and handling the build. That's it. No features. It's just supposed to be, it is purposely thin. It's the whole point. And it's the aggregate version manager. Like a version of shell represents a combination of all the versions of the children. So that can give you an idea of, it's version management. And so here's an example. It's a lot of code on this page. What's happening is it's saying, hey, there's an array of routes that tickets has, an array of routes that schedules has, an array of routes that home has. You stitch them together to make sure to create one unified router. The idea here is there is one top-level view build. And our view build isn't that different than any other view build. It's a regular view application. But where it's finding information for its routes and stores and things are not local. They are independently released child applications. Another example here is this is just the same idea with some state stores. It doesn't create the state stores or the user store, the ticket store. It just stitches them together from children. So yeah, the idea here is, like I said, it's purposely thin. But because it's using regular view CLI, we're still on view 2. So we're using regular view CLI, so you can have like general niceties like max asset size, max entry point size, all the general control you have over the build at build time that view CLI and any other manual things you might build, you have access to. Here's an example using semver, because the idea is, because these dependencies have dependencies and they're all shared, it's kind of important to make sure you're doing semver for things like this. And so here you'll see, for example, the tickets app is a child of the shell. So the right is a tickets app, the left is a shell. You'll see that it references a direct version, a specific version of tickets. So it's 0.10.0 on the right. So actually you see it's exactly 0.10.0 on the left. But its peer dependencies is a range. And so if the tickets app needed something from a shared component library, like a new feature or something like that, it would define its range of supported versions of that child app, so semver. Now we're going to talk a lot more detail about some of the CI steps that I went through in that larger flowchart a moment ago. So here's that flowchart again. And you'll look, this part on the left is going to be the child CI. You'll see it starts with a pull request and ends with a new version going to NPM. We're going to go into detail there now. So here's just a quick example of a stage CI for our children. They're going to build themselves. They're going to do some general testing stuff, static analysis, and like security audits for NPM packages, general unit tests. We have a little nicety we wrote for in this specific app, it makes sure that no specific external dependency falls more than a couple minor versions behind. And if it passes, it publishes it to NPM. And here's just that same idea in YAML. You might have seen this if you use any versions of Docker or Circle CI, things like that, where you're going to define your stage CIs and your stages in your CI and their order. And so how do these things actually communicate with each other? We actually use mostly just Git hooks with all the different child applications just notify our build system whenever certain events happen in Git. So here's an example of just linking into pull requests. When pull requests are open, created, merged, closed. What I was saying earlier on, we would automatically create a new version when something was merged, or we would create QA branches of for feature testing when a PR was opened, and then close those down when they're closed. So this all happens through Git hooks. And that was a child application, which is much more simple. The shell application is a bit more complicated, so we're going to go there now. And so you'll see the first 3 steps are very similar. You're going to build it, you're going to run some testing, you're going to publish it. But in this case, because the shell application is not an NPM package, it is a set of JavaScript assets, publish means build the assets and upload them to an asset server. And so that means that you see that's early on in the pipeline, because once you get to child integration tests, which is a 4-stage, you need those assets somewhere available for our end-to-end test to actually query against and actually exercise. And so, so at this point, let's go back real quick. So what's happening here is a child application has created a new version. It has created a pull request to the parent that has passed all nicely and good to go. So it merged. And so now we're going to create a new version of the parent, of the shell. So like I was saying a second ago, it goes over to publish. Now PR module publish here means you can actually ignore the word PR there, because really it's module publish. What's happening here is once it's releasing itself, it is not tied to a child anymore. So it's just going to release master as the state it's in. And so that means it's basically just going to bump the version that it's currently at to one newer one, and then upload all those assets into our asset server and include that version number as part of the URL in that part of the path to those assets. So that way it gets automatic cache busted for the new assets, and these assets are all designed to be immutable. They won't change. Version 1 will always be version 1. Version 2 will always be version 2. You're never going to go override a version. And then once they're all available there, it'll run a bunch of child integration tests against this new version. This is now going to be an umbrella suite. Because you don't know, on purpose, you're not tying these end-to-end tests to a single child. It's going to run the entire umbrella suite of all of our end-to-end tests to make sure it's all safe. But these are slimmed down to make sure that they're only testing what's important, because, like I said earlier on, end-to-end tests are notoriously slow and flaky. I've battled them a lot over the years. And then you can do additional things, like we have some accessibility tests we add on top of that. And then you go to release. So for our sake, release, all that release means is notify our clients that there is a new version available. So because they're already in the asset server at this point, behind that version number, our clients, there's a little system that just says, we tell them how to construct a path to the assets. And it'll just have a new number there now. So now with the next request, they'll get a whole new set of assets for this new version. And this is just the same idea earlier on of the YAML describing the stages of the parent shell CI. So just a quick talk over about some of the stuff it's doing. Really nailing down how many safety nets have been put in place. Because the idea is you've got so many different developers across so many different places and so many different levels of skill. You need a lot of safety nets. And so static analysis is a basic. You definitely need static analysis across all of them. Bundle verification. So one of the things that happened to us was, that kicked this whole thing off, was our bundles started getting larger and larger and larger. And so we started mitigating it some by doing Webpack pack splitting, things like this. Still, they kept getting larger and larger and larger. And so one of the things we did was we started using regular view config, view CLI. There's options in view CLI to don't let a single bundle be a certain size, things like that. But that made it so that one person could make a bundle so big that you could no longer add code without trying to refactor somebody else's code. So when you break this up into small applications, any one bad actor, one person who's being irresponsible, doesn't break everybody else's code because we're no longer in the same pile. All that would happen if one of the child applications had too big of a bundle, they would stop being able to release because CI would stop them, but everybody else could continue all they want. NPM audit, always got to do that. General unit tests, but the idea here is, for example, because we were all in one big pile originally with a bunch of different teams doing a bunch of very different things, a bunch of different skill sets, different chunks of the code base had different test coverage, different code quality. Like some of them were very neat and organized, some of them weren't. Some of them had really nice formatting, some of them didn't. And so so splitting it up gave the individual teams the freedom to be as strict or not strict as they wanted to, as long as they matched the contract back into the bigger shell application. Automated testing, absolutely required for this kind of thing, especially if you have like an SLA, you need to stay up. You need automated testing, including we've also done like New Relic synthetics, things like this. There are multiple layers at the top to make sure that this thing stays up. And then you can do any custom verification for your specific use cases. Like we had certain common patterns that would creep back into our code base quite often. So you can add custom verifications to different CI steps based on the use case of a specific child or in the parent itself. Now we're going to go into the deployment. So here I keep on alluding to this versioning system that our clients use to determine where to fetch the JavaScript assets. So here we actually call it BLUI core. Really should call it BLUI or Connect.Tech version. But the idea here is just that there's a versioning system that that can be fed into our clients so they know how to construct the URL to the assets. So foo.com or assetserver.com /0933.0/app.js, things like that. So they're all behind this version number. These are all designed to be immutable, so caching can be kicked in caching. And so, this is just a simple trying to reiterate that point. Our build system will upload it to an asset server, and the client browser will just request it from that asset server using the URL based on that versioning system I showed a second ago. And now I'm going to pass it to Alex, and he's going to go into what it's like to actually use this thing as a developer.
Thanks, Nick. So is everybody following so far? Great, cool. We've only ever given this talk to like our coworkers who like know how to use the system, so we like weren't sure it would come through, but that is great. And feel free. I know we jumped through the code snippets. We'd be happy to like dig into those deeper too, if you guys are interested. Do you feel like this is something you could build or that would maybe benefit you if you have a large-scale application?
Maybe I have some questions afterwards. Just to make sure that I do understand what I think I understand. Essentially what you're saying is that you split your the app into smaller, we're going to call them components, right? But those child apps, to use your analogy, you're publishing those as NPM packages, and then you're consuming them in your shell. And then you have a custom CI system that kind of registers and does like the various different pieces based off of the hooks to make sure that everything gets tested and deployed correctly. Is that accurate?
Perfect.
On the button.
All right, it's working. Great, thank you. Okay, so we're gonna, to further drive the point home, we'll talk through kind of what is the workflow for a developer, like if I'm actually releasing a PR, and then we'll go into like maybe some specific technologies that we're using, and then we'll discuss. So that was your sort of midpoint check-in. So, for our use case, the Connect.Tech like example website that Nick was talking about with its child apps for ticketing and the home page and the navigation or the a schedule widget or whatever. Let's say I'm working on that, and my product owner comes to me and is like, we want to add a new VIP tickets package within the ticketing app. And so like, okay, great. I build the functionality. Maybe I work for someone who's doing the back end or something. Maybe I build that myself, and that's a whole different system. But for the front end, I built this new feature within that tickets application. I add tests around it. Those tests pass when they run on my PR. When I like create my pull request. Then I put a tag on this PR to like kick off those builds that in that Docker container, and it runs say integration or end-to-end and accessibility tests. And let's say in this case, product was like, I don't want you to release it. I'd just like to see the thing work before it like goes out. And so I haven't merged any code yet. I've just created a pull request, but kind of like Nick was talking about, there's now like in our beta environment, we have a URL that I can pass to QA or my product owner. And they can see the entire website, like the latest build of it, that's got my little changed application running within it, which is very cool. So they can give me feedback on it. And yeah, that way if I accidentally have broken something else or there's some other issue, that gets surfaced too. We're like running the whole thing without yet having merged to master. So that's like a nice happy path. And then even better, we'll say that like they like my implementation of this VIP tickets functionality, and they're like, okay, go ahead and merge it. Like we can release this. It looks good. So I merge, and as Nick explained, this blue box here in this like flowchart covers everything else. Like all the end-to-end tests run, the overall full front end is built, it is released, the version is incremented for the clients, and they all get this code. And so we have a release engineering team, but they only need to step in when something goes wrong, basically, or when we need updates. They actually spend most of their time sort of coding and adding new features, not manually putting out like releases. Yeah.
Right, going back one slide, when a child app is created and the shell is deployed for QA, are those unique URLs for each time the child app is tagged for the shell, or is there only ever one QA instance running? The question behind the question is, do you have like multiple instances of your QA data that each pull request runs against, or do you just have one data store that they all run against?
So just, yeah, it pulls the data from it. We have like a beta environment where we'll like copy example production data into that we have as we're like developing, for example. So yeah, there's just one environment. And if I like update that pull request, for example, like it will rebuild and effectively re-release with the same like kind of pseudo version, and it goes into the parent. Because the version is actually like, I think it's the pull request number is like how we do it. So I effectively overwrite what I currently have if I like change the pull request. And then yeah, all of our beta environment is just, it's the same like example data that everybody uses. Yeah, so then the case of a sad path where there's something wrong with my VIP ticket functionality. QA, catches it. QA is like, hey, it turns out if I put 99 tickets in my shopping cart, I can't check out. What's going on? Who knows? Something is an issue. Or they're like, hey, I can put negative numbers into the like input form, and like you're accepting that and sending money to the customer. Whatever. The QA catches it, and they either contact me, or we use like Jira for version management. They leave a note on the ticket, and so I have to do an update. And kind of like your question asked just now, like if I then change the PR and modify it and push up some changes to the code, it kind of automatically just runs through the same cycle again and then updates that like beta version. And then in the case of the rare emergency abort, say for whatever reason QA didn't catch the negative number issue or whatever other thing happens, we've released to production, and then our help desk gets a call, and someone's like, hey, I can't buy a regular ticket, or who knows, or like my tickets have disappeared, something bad has happened and there is an emergency. We can very easily roll back. So this red box, everybody is like worried, but for us, because of that version management tool, we can be like, oh, just give them the previous version of the front end before my individual piece went out with it. So we can roll back the site seamlessly, and so we just have to cache bust that like kind of permissioning system or whatever, and we just say like, no, now you load this other version of the front end. And everybody does. They load the version of the front end that works before my code went in. So nobody has to like freak out. We don't lose any progress really. And then I can just, roll forward and merge a fix to master to like push the fix out, or maybe I just completely revert my code, my pull request, and we push out a version of master with that. So yeah, it makes things pretty easy to like, we put all this work to the system, and now we kind of like just cruise around building features without so much having to worry about deployment, which is cool. So how could you do this if you were so inclined? In the beginning, like so many processes in engineering, is you have meetings in the beginning. So you start with, you can conceptualize the application as some standalone apps. So perhaps if you're working on an application that has a few hundred components, you're at the point where you could really break it up into feature-specific tools. Or if you have different teams, that's an obvious boundary where maybe each team could own its own repo and part of the application. So you have some meetings, you figure it out. When Nick and I were drawing the red boxes and the blue boxes on top of the website before, like, for us, it's like we almost think of the site in terms of that. And Conway's Law, like your site's gonna look kind of like what your teams look like. Then you write some documentation because now you're sort of working in a greenfield project, so make sure it's good. So if you like break out your generic components into a generic components library, like spend the time and write working markdown example files. Like make sure everything's very well tested. And you can have that be like bulletproof. And if you know your generic components are bulletproof, you're much more confident when then building a more complex page, for example. Know who the code owners are, work out a review system. If you we, for example, the team that owns the code base, someone in there has to weigh in if someone from another team wants to like contribute to like, if team B wants to contribute to team A's like repo, their thing they own, one of their code owners has to also look at the PR and approve it. And then get started. It's very easy. As Nick said, the shell application is really just a thin view application. So, we would use Vue CLI, but yeah, use your view builder and start an application. And then if you're working, presumably, already on like a big monorepo, big view application, you start just moving code over to these different child applications. And then you need to implement some kind of containerization tool. So we use Docker. You can get up to speed on Docker if you haven't used it before. It's like half a day of like a couple free videos on YouTube, and you'll know what you need to know to build something like this. But there are also services that do this. So Circle CI is one of the sponsors of this conference, and Circle CI does this basically as a service. It's like integration pipeline as a service, which is pretty cool. So it'll hook into your GitHub repo or repos to do this kind of automated testing and deployment for you, which is pretty cool. And then in our case, as Nick talked about, we use Git hooks, or if you're using GitLab, they have an equivalent function. It's just a tab. There's a tab, and you can be like, hey, when there's a pull request, I want you to send a message to this URL. And like, that's my Docker instance that's building core. So it's all like, when I first was like learning about this, as we were building it, we were like, surely you can't, like, that seems very complicated. And then we're like, no, it's actually just a tab in GitHub. This tool's been here the whole time. So it's kind of cool. It's not, none of this is like daunting, I guess is the thing. Once you kind of have built it, you look back and you're like, oh, it wasn't that impressive, actually. So I'm going to hand it back to Nick one more time. We're going to tag team. Oh, sure.
In your example, one of the exports from one of your features was routes. So is the assumption there that each one of your features are URL route dependent? Meaning you can't have a feature share, two features exist on the same page?
So they, in that sense of routes, generally, like a lot of our routing is for the API itself, and then generally our routes, I think, is like a lot of the stuff that gets built or exported, for example, is actually a child of some larger page, kind of depending. That's actually like kind of a nuance, I guess, how we do our navigation versus how individual pages work. But generally, they don't share. It seems to work out that way. How our architecture's evolved, that like that analytics page that Nick showed has its own URL and set of routes. The document viewer has its own like /document/ID routing. Our search results have their own routes. So for the most part,
so then for that feature to be exist, then the shared page components like header, footer, navigation.
Yeah.
That separate module. What if you have? How do you handle the situation where you have a breaking change in that shared component library that all of your features then have to adopt? Is that a major release? Or
That would be the major, like with Semver system, leading into Semver, that situation. And so to talk about Semver with the example you just brought up, with like the widget on the right, that might be part of a bigger application. If that was part of a shared component repo, then like the child application that was loading it in would actually just define the range that it would support, and so that child one could actually get bumped, even though it was a dependency of like the shared application. The parent chooses the actual version because it's just a peer dependency. And so you can actually bump dependencies of children without actually releasing the children. You see what I mean?
We can just jump into the discussion.
Yeah, basically.
Nick, you should hop on the stage so you're on the camera.
Yeah, good call. So yeah, the idea is we're going to get ahead of a few questions that might come up. Single SPA is one of the things probably anybody who's used it before are probably screaming when they're talking about it right now.
Single SPA does this.
It's so very similar to this.
Well, I knew that this part of the talk was coming up, so I held off on asking, but I was wondering kind of why you guys went with your approach as opposed to single SPA, what the pros and cons were.
It was down to granular control at build time. So you're talking about earlier on where like the view max asset size, right? You have one singular build. If anybody in the entire pipeline, breaks that rule, you can't get over a certain amount, it stops the CI, doesn't go out. But in a single SPA world, whatever's at this URL goes here, whatever at this URL goes here. So if one bad actor could bring down the whole page. So yeah, it came down to we wanted really granular control at build time. And then module federation was another way you can share some of this stuff in a single SPA world. Also, sharing assets is a big one for a build time. You have one top-level build, and so it's choosing the versions of all your dependencies. You use regular peer dependencies, so it's one version of a shared component library, things like that. In a single SPA world, it gets more complicated. And we started this back in 2019. That was back, I believe that was before Webpack 5 was released, and so module federation was either not even available or very new. And so sharing dependencies within a single SPA world was different and difficult at that time. You kind of had to do it yourself. Yeah, and I guess I'll just reiterate, yeah, we wanted programmatic control of all the assets at build time. So that was that part. Yeah, and so the idea is, thank you. And we were going to open up to questions if you wanted to go into any detail of any one part of that, because a lot of the arrows we showed between the flowcharts could be whole talks in themselves if you want to go into some detail.
I do have a quick question. I guess if people want to run with like the entire suite locally and just run the shell app, and then are they like using NPM link for?
Exactly, yeah. So yeah, if you just clone, the shell app and then start it, you're running the entire application. And then if you want to test like just the shared component library, right? You can link just that one because the parent build chooses the versions. Yeah, it'll show you across the entire site what those changes would do.
What would you say is the downfall of this organization structure?
One of the hardest parts for this, which is going to be hard no matter what you do, would be, for example, we're looking into a Vue 3 upgrade. So that's a major version of a dependent library. How do you coordinate that in a clean way? In a single SPA world, you could have a full build end-to-end with a whole separate dependency tree for that part of your page and a whole separate one over here. But when you have a single top-level build, how do you deal with breaking changes to dependent libraries? It requires a whole lot of coordination across all the teams and probably feature branches of lots of parts of your stack. So you're going to be maintaining two versions of your shared component library, one for Vue 2 because you're going to prod, one for your ongoing work trying to convert to Vue 3 and things like that. That's the biggest challenge I think I've seen. I appreciate it.
Thank you.
Oh yeah, we're on the countdown now, right? We've got like 11 months until LTS ends. So yeah, we're looking to it.